Guys, welcome back to my YouTube channel. We're still under Mechanotechnics N6. We're still under bend bricks, right? All right, so we did part one. This is part two. I would advise you to watch part one, and also there's introduction. You can watch the introduction. By the way, if you have not subscribed, may you kindly subscribe to my YouTube channel and click that notification bell so that you'll be notified whenever I post a new video. All right, I've given example 3. Read as follow: a band brick layout is used on an elevator drive is shown in figure 3.8. Okay, here it's our figure 3.8. um Here it is, guys. You see there that it's our okay, right, as you can see. All right, so the brick, as you can see, the bend brick force, all right, F, the bend brick force F is applied to the end of the lever. Okay, here it is, to the end of the lever, you can see there. All right, the lever hinges on a fixed point. Is fixed point, the stationary, like is fixed there at point 0. As you can see here, it's fixed there. All right, at point there 0 there, it's fixed there, as you can see. All right, we see that it's fixed. All right, guys, as you can see there, they've used something there to fix that. All right, then the constant says the lever. Oh, okay, we have done that statement there. Then constant says the torque exerted, we've given the torque is 3,800 newton per newton meter there, newton meter. And the drum, given the drum diameter is 900 millimeter, the coefficient of friction is 0.28, the angle of contact is this. Take note, it's in degrees, supposed to be in radians. Okay, we'll divide this by 57, guys, 57.3. If we convert that to pin radians, okay, we know that from N4, guys, there's no change there. So if given the torque, what does the question say is actual? What do they want? Let us go down. Says calculate the brake force F, or okay, to give the torque, that gives the torque of that in Newton meter. If the drum rotates clockwise, first we start rotating. B, if the drum rotates anti-clockwise. All right. So let us go this one, guys. It's in if you've listened to my other video, I've shown you guys. I've said okay, firstly the drum is rotated where clockwise, the drum there clockwise. Or you want me to show the arrow here to show you that is rotating clockwise? On the top of the drum there is clockwise. Remember, this is right. If the arrow is pointing on the right, this is clockwise. This is left, it's anti-clockwise. Anti-clockwise when the arrow pointing to the left, like that. When your arrow pointing to the left, that is from there, that is anti-clockwise. So this is clockwise. So you can see this will rotate this clockwise. I said T2 will oppose the direction of rotation. T2. So remember, this is rotating like this, will oppose this direction. Here we'll have T2 opposing, like will face, like it's opposing like this. You see T2 will be facing at this, will be acting opposing, will be opposing, right? Then this is supposed to be what? T2. Then T1, guys, like this, T1, By the way, someone might ask, oh, okay, let us will discuss about us. By the way, this is T1. T1 will be acting in the direction of the rotation. Remember, this drum is rotating like this. Remember, the drum is rotating like this, is pointing there. Even T1 must point towards the same direction, acting in the same direction. That is T1. You must take note about that. So this is nice, guys. We have our beam now, by the way. So this is acting on the 90, whereby is what is needed actually. This is acting on the 90. Also, this is what is 90. No, so there's nothing we can do here. We don't have to do vertical components and what we don't break it to component because it's acting on the 90. It's supposed to act on the 90. This is right now. We can just use this as our beam. Now this is our beam. See there, that is a beam. This force is acting upwards. If you don't understand, if this you see the arrow is pointing upwards, always, if it confuses you guys, you can write it like this. Here, you can point it down, or I can break. I can break this for you guys if you feel like. If this is confusing you, let us break this beam down. If this you feels like it's confusing like this, I can break this beam for you guys like that. We have this beam goes until there. This black is it makes things to disappear. All right, why? Let me check. All right, let me break this beam for you guys. Oh, it makes it to become. Oh, I understand. The color of black makes this highlighter not be seen. All right. So by the way, let me just draw this. Here it's our beam. I will draw the beam. It goes until there. This is our beam. Here we have the force pointing. We have the force there pointing where downwards, which is F. The distance like that. You have a distance here. Okay, this is T2. You see it's pointing upwards. I'm just breaking. Write it on the bottom if it confuses you. T2 is acting upwards like this. I can show you. This is what. This is T2. All right. Then here we have again T1 is acting upwards here. We have T1. The distance here till there 6 millimeter, 600 millimeters, same as 0.6 meter. All right, that is the distance there until there. Then the distance here we have a pivot. It's where it's fixed. It was 0 there until there. The distance here there will be 0.08 meter, right? Then this distance from T1 till there is 20. The distance here from T1 there where T1 is 18 is 20 millimeter. Then this will be 0.02. Right, so this is the beam, guys. So this is how you can convert this to a beam. Then okay, do not be confused, guys. This is how you can convert this to a beam. You can convert this to a beam. Understand, this is the pivot there. So sorry, this one is the pivot, which is point. We take it as what is 0. It's our reference there, so it's our point there. So yeah, can do now. We have our beam. Can say A. Can start by finding you can find by, let's start by finding the ratios. T1 over T2 is equals to E, like that. This is E, coefficient of friction. From here, from our state is 0.28. This is 210. So this is 0.28. The one is it is what, 110 degrees. You divide this by 57.3. So you can use it same time. You can plug it here same time. 240, right, or 210, sorry about that, degrees, divide by 57.3. So if we punch this, we'd get this to be equals to what, 2.9, 2.79, right? This is T1 over T2. So then you multiply there, you'll have, therefore T1 will be equals to 2.79 multiplied by T2. This is simply what the ratio. All right, the aim now is to find, we want to calculate the torque. We know that the torque is T1 minus T. We want, okay, so we don't want to calculate the torque. Sorry guys, we want to calculate what, the force, the force. The force, right? So want to calculate the force, by the way. So we're supposed to have the value, or when to calculate the force, no problem guys. Then the force, will get the force from here, from what is this, torque is equals to T1 minus T2 multiplied by the radius. We have the torque. So we're supposed to have now T2. In order to find that, we'll get there. Okay, we'll see. Let me not confuse you, but we will see what we are doing here. So let us, you understand, right? This is what we have. So we have given the torque. Let us use this torque, 3,800. Let us take advantage of that torque. Or we know the formula for torque is T1 minus T2 multiplied by the radius. All right. That is what we have. The torque is 3,800. We don't have T1 is this, isn't it? It is 2.79. T2, right, isn't it? T2 minus T2 into the radius of this drum. What is the diameter there? Is 900. Then 900, you'll divide this by 2. This will be 450 millimeter. Then you divide by 1000. 2 pin meter will be 0.4 meter, 0.45 by the way, meter. So that is our radius multiplied by 0.45. All right, then the rest is here, it's a math. Then can divide by 0, okay, do not do that. Still it's the one and the same thing here. We have 3800. Now it's a matter of maths. 3800. This is a like term, is the same as, like, remember it's T2 is the same as like T2 minus 1. This will be 1.79 T2 multiplied by 0.4. Okay, multiply this and this, or you can have T2, you know the maths, you can make it fast like this. Then we divide by 1.79 multiplied by 0.4. 4 5. It's 5, guys, by the way. 4 5. So yeah, therefore T2 will be equals to 1 now. Therefore our T2 will be equals to, let me write this T2 nice, will be equals to punch there 4 717 comma 57. By the way, I've rounded this to 2 decimal places, but on your exam please round it, everything rounded to 3. On the exam round it to 3 decimal places, but going forwards I will use maybe 3 decimal places if I want, yeah, depending on the instruction, but nevertheless this thing is the one and the same thing. All right, so just follow your exam instruction there. Your 2,79, then substitute. We have T2, we have now that is 4 4 7 like this, 57, then T1 will be equals to 1316 Newton. Right, we have T1 and T2 now. Why did we need this? It's because from the beam now, is from here will be limited. It's where we can get the force, because we're supposed to know the value of T1 and T2. Remember, from here, the beam here, we have T1 which is unknown. That is why we have T2, T1. This is also T1 here, which is one is unknown. So that is why we calculated T1 and T2. We wanted to know these values. Now it's nice because we know T1 and know T2. Then we can take the clockwise, which direction when it's rotating the this beam, it's when it's rotating when it's rotating clockwise. We've taken this when our drum is rotating clockwise. Then we can use the sum of moments acting clockwise is equal to the sum of the moments acting in the anti-clockwise moment. So the force here, as you can see, will be acting where? Clockwise. There we have that force, which is force multiply the distance from the pivot, from our pivot, which is this one, is here until there. You add 0, 0,6 plus 0,08. We add that, right? If we add, let me see, 0,6 plus 0,08 is there. I want to check here. It was 80. Let me say 80 divided by 1000. Yes, 0, then the one is 0,6 plus 0,08. Okay, this will be 0,68. All right, multiply by that distance will be 0,68. It's equals to only this one. This is acting there anti-clockwise, and T, yeah, is acting anti-clockwise. This one, remember, we have this, the beam will be rotated, this will cause it to rotate anti-clockwise. We also have T, sorry, again T1, if you can check, guys, will cause this beam at that, remember here it's our point, will cause it to rotate like that clockwise again. So we'll have to add again T1 multiply by this distance, which is 0,2 from there, 0,02. Then this would be called the anti-clockwise one will be T2. Then we have the T2 multiply by this distance, which is 0,08. All right, then we've calculated the force, isn't it? We need the force actually. T1 we did calculate it. We found that this to be 13162. Then we'll multiply this into 0,02. Then T2 we got that to be 4717.57, multiply this by 0,08. So then yeah, you can subtract them. We know the math. Subtract, then we divide. Okay, let's go by the maths. I want F straightforward. Subtract there. Take this, we'll subtract that side. Then we'll have this 4717.57 multiplied by 0,08 minus 13162 multiplied by 0,02. Remember, we have this here. Then we divide by 0,68 both sides. So our F will be what? X1. If we divide by that, divide by 0,68, then we know we punch this on our calculator. Therefore our F will simply equals to 168 Newton. Okay, this is what we know. Newton. All right. So this same beam, we'll be using it, but now we change. Remember, now we change the direction, the rotation, guys. If now we rotate, only we must notice something. If we remember now, it was clockwise. Now they say we should calculate the force again when it's rotating where the trim anti-clockwise. Only T2 and T1 will change. Check. If we are rotating now, this, check this, guys, these two will change now. Check. You are rotating now anti-clockwise. All right. T2 is opposing now. This one will be no longer be T1. This now will change to become what? T2. This will be no longer be T0. This will be T1. So what you have noticed here, only this will change on our beam. Simply change this, guys. Come to our beam. T1 and T2. Only T1 and T2 has changed. So we can come here. We change this, guys, here. This will be no longer be T1. T2 will simply equals to T1. This will be no longer be T what? T1. This will be equal what? T2. Cannot here. Let us use this now. This diagram. Just changing things. Then you take your moments again. Or let me write here on this new page. Sorry about that. Sorry about that. Okay. Now we'll change it just the moments. T1 and T2 will only change. Now the values will be the same. Taking moments. Still we're taking moments at the pivot. Okay, there are the sum of clockwise moments. Must be the sum of anti-clockwise moments. Then we know what to do, guys. Clockwise. Okay, this is F will be rotating like this, which is clockwise. It's what now? It's F, right? In actual fact, this thing, you see, okay, yeah, we have the clockwise moment, which is F. There, we're acting clockwise, F. The distance there is, we sum up this and that, be 0,68 plus which one again? T2 now is acting also anti-clockwise. Clockwise, they will have T2 now, multiplying by 0,02. This will be called, what is acting clockwise now is T1, acting at 0,08, multiplied by 0,08. So one, the force is 0,68 plus T2. We know the value of T2, guys. We did calculate that, which is 4717,57 multiplied by 0,02 is equal to the value of T1 13162 times 0,08. All right. Now, oh dear, wait, 0,068 F, right? Then we know the maths. You take this to the other side, will be negative. All right, we know the maths. Then F will simply equals to, you know the maths, 13162 and 3162 times 0,08 minus 4717,57 times 0,02 divide this by this, guys, by 0,68. We know the maths here. Therefore, what will be the value of F? Simply equals to 14, like that, 1410 newtons. So this is how you get this, guys. So this is how it goes. Not so you've obtained all of the marks. So thank you guys for watching, and then please feel free to like and comment, and then feel free to share this to your fellow classmates, and then you can please subscribe if you have not subscribed. And then if it's your first time watching this video or watching my videos, please kindly subscribe to my YouTube channel. All the best.